Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in exercise 12.1 third sum. So here the given question is solve the linear programming problem graphically. So basically the given linear programming problem is we are going to solve graphically and get the solution. Okay. So maximize z equal to 5x plus 3y. And here what is the given constraint? 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, then x greater than or equal to 0, y greater than or equal to 0. First, I'll tell you what are the steps to get the solution, then we can move on to the solution part. Okay, the first thing is the given constraints. So, given constraints are basically these inequalities. Okay, so these inequalities, what you are going to do is with this help of these inequalities, we have to find the common solution space for all the four inequalities together. Okay, so what is the first thing? For the given inequalities, identify the common solution space. Common solution space. That common solution space, technically we call it as a feasible region. Okay, for all the given four inequalities, if the feasible region exists, then solution exists. Okay, in case if there is no common solution space, then there is no solution for the given z. Okay, so common solution space we have to identify. Then second is we have to see whether it is bounded or unbounded. Okay, so bounded is the common solution space, you will get it as a closed figure, some polygon you will get, so that is bounded. In case you have a common solution space but it don't seems like a closed figure, then it is unbounded. Okay, we have to check whether it is bounded or unbounded. So if it is bounded, what we need to do is identify the corner points next. So corner points are the given inequalities. So using the given inequalities, first we will be drawing a lines, right? So the closed figure wherever the two lines joins, no, so that is the corner points. So you have to identify the corner points. After identify the corner points, what we need to do is one by one you have to substitute in the given z. Okay, that corner point one by one you have to substitute in the z. Then here what is the z here? Maximize, they're asking us to maximize the z, no. So on substituting which corner point, you will get the maximum value. Okay, so that will be the result. Okay, this is how we have to do. In case if it is unbounded, same, identify the corner point, then we have to substitute it. Then the whatever value will get maximum value, that may or may not be. So again the given z itself we have to take it as an inequality, then using that maximum point, then further we need to proceed. Okay, so while doing the unbounded sum, I'll explain that. Okay, so if it is bounded, what we need to do, identify the corner point. That corner point one by one we have to substitute in the z. Okay, so let's get started. So what is the first step here? Common solution space we have to identify, no. So for that what we have to do is the given inequalities, okay, I'm going to consider as a equation. So let 3x plus 5y equal to 15. To draw the line of 3x plus 5y equal to 15, we need 2 points. Okay, 2 coordinate points are required. If x equal to 0, then what will be the y? 5y equal to 15, 5 ones are 5 3 times. So y will be 3. If y equal to 0, what will be the corresponding x value? So 3x plus 5 times of 0, which is 0 equal to 15, then 3x equal to 15, 3 ones are 3 5s are. So that means x will be 5. Now these two coordinate points, what we are going to do is, let's plot it in the graph. So if you have a proper graph, just practice on it. So I'm just drawing x-axis and y-axis, and with the help of the points, I'm going to draw the graph here. Okay. So uniform space should be given. So between one point to one point, try to give the uniform spacing. So if it is a proper graph, no problem. Since I'm drawing it in rough, I'm giving an equal space. Okay. 11 and then 12. I think these points are more than enough. Same way in y-axis also, let's consider 1, 2, 3. Okay, now these coordinate points, let's substitute here 0 comma 3. So 0 comma 3, where do we have? So this point is 0 comma 3 point. Okay, 5 comma 0, this point is 5 comma 0. Now on joining these 2 points, what we will get? We'll get the line of that equation, that is 3x plus 5y equal to 15. So 3x plus 5y equal to 15. So this is the line of the this particular equation. Okay, now what is the given inequality? 3x plus 5y less than or equal to 15, right? So we need to identify the solution for this. Okay, so after drawing this line, that is red line, that is 3x plus 5y equal to 15 line, the graph is dividing into two portions. One is above, other one is below. So we need to identify where the solution exists for the 3x plus 5y less than or equal to 15. Okay, so for that what we are going to do is randomly take one point from this portion. It can be any point. Okay, so 6 comma 1 or 6 comma 3 or 8 comma 1, like that, any point you take it. So let me take 6 comma 1. Okay, so 6 comma 1 I'm going to consider, and I'm going to substitute in the first inequality, that is 3x plus 5y. 3 times of 6 plus 5, uh, 18 plus 5, so which is 23. Is it 23 is less than or equal to 15? Is this true? Which is wrong. So that means the solution of the 3x plus 5y equal to 15 we don't have in this particular portion. So then obviously we will have in the second part. So here only we will have a solution. But anyway, let's confirm. Take any point from this particular portion. 0 comma 0 shall we take? So 0 comma 0, just take it and substitute it over there. Then what we will get, which is 0. So is it 0 is less than or equal to 15? Yes, which is true. So you take any point in this particular portion, this side, it will satisfy the inequality. So that means we have a solution for the first inequality this side. The solution space for the first inequality is this side. Now same way we have to identify the solution space for the second inequality. So what is the second inequality here? 5x plus 2y less than or equal to 10. So first we have to draw the line. So for that I am going to consider the given inequality as a equation. So 5x plus 2y equal to 10. To draw the line of that, we need minimum 2 points. If x equal to 0, then what will be the corresponding y? If x equal to 0, 2y equal to 10. Then 2 and 10, if we cancel, 5. If x equal to 0, the y value will be 5. If y equal to 0, then x will be 5 ones are 5 2 times. So y will be 0. Now these two coordinate points, let's substitute. So 0 comma 5. So 0 comma 5, where we will have here? So this particular point is 0 comma 5. And the next one 2 comma 0. So this point will be 2 comma 0. Now joining these 2 points will get the line. So this line is what? The equation of 5x plus 2y equal to 10. 5x plus 2y equal to 10 line is this yellow one. Okay, now after drawing, forget about the previous one. After drawing this yellow line, the graph is dividing into two portions, right? One is this right side and the other one is left side, this side. Okay, so we need to identify the solution space for the second inequality. You take any point from this side. 0 comma 0 itself shall we take? Okay, so 0 comma 0 I'll take it and I'll substitute. Then what happens here on substituting? So 5 times of 0 0, 2 times of 0 is 0, which is 0. 0 less than or equal to 10. Is it condition true? Yes. So it is true. So then what we can say, you take any point from this side, it will satisfy this second inequality. So what we can say from this, the solution for the second inequality lies this side. Okay, so we have a solution this side. Then third one, x greater than or equal to 0. So x equal to 0. What is the x equal to 0 line? X equal to 0 line, what is that one? Y axis only, x equal to 0 line. Okay, and what is the inequality? Says x greater than or equal to 0. So that means the first quadrant and fourth quadrant will be the solution space for the, just keep it in your mind. Okay, first quadrant and fourth quadrant will be the solution space for the third inequality. And then for the, sorry, fourth quadrant. Okay, now and then for the fourth one, y greater than or equal to 0. What is the line? Y equal to 0 line is this x-axis will be y equal to 0 line, and solution space for y greater than or equal to 0 is first quadrant and second quadrant. So in common for these last two inequalities, in common, what is the common solution for the x greater than or equal to 0, y greater than or equal to 0 is the first quadrant. So that means only in the first quadrant your solution lies. In that first quadrant, first two inequalities, where do we have a common solution? Only common solution we have here. I'll just identify. So this is the common space for the all four inequalities. Just like a filtering. For all the four inequalities, where do we have the common space? Here. This small portion is the common solution for the all the four inequalities. Okay. Now, since it's a common space available, whether it's a feasible or not, feasible region is there. So we can say feasible region exists for the given z, for the given z, feasible region exist. So solution also exists for this. Okay, and feasible region is a closed figure. Are we are getting as a closed figure or not? It's a closed, it's not a open. No, then it is bounded. And for the bounded corner points also very well we can identify. No, so here this point is 0 comma 0, and this point is 0 comma 3, and this point is 2 comma 0, and we don't know this point, right? What we can do is, this particular point is line joining of the two equations, that is 3x plus 5y equal to 15 and 5x plus 2y equal to 10. So using the elimination method we can able to identify these 2 points. Okay, so roughly let's do it. So 3x plus, first equation is what? 3x plus 5y equal to 15, and the second one is 5x plus 2y equal to 10. So shall we eliminate y first? Then the first equation I am going to multiply with the 2. 6x plus 10y equal to 30. Then this one I'll multiply with the 5. So 25x plus 10y equal to 50. Changing of the sign, cancel. So here we'll get it as a minus 19x, and here minus 20. Then what will be the x value? Minus minus, if we cancel, 20 by 19, we are getting it as a x value. Now to get the y value we can eliminate the x. Okay, so or this x value, if we substitute in any one of the equation also, we can able to get the y value. Okay, so I'll substitute in the equation 1 itself. So 3 times of 20 by 19 plus 5y equal to 15. So which is 60 by 19 plus 5y equal to 15. Now 5y equal to 15 minus 60 by 19. So here if we take the LCM, we'll be getting 285 minus 60 by 19, and here 5y. So now 285 minus 60 gives you 225. So 5y equal to 225 by 19. So now 225 divided by 5 gives you 45. 5. Okay. So that is what is the y value? 45 by 19. So that means this particular coordinate is 20 by 19. And then y coordinate is 45 by 19. Okay, so let's also name the corner points O, A, B. Let's take this as a C. So O, A, B, C, O will be the bounded. Okay, so it is also bounded. So that is what? O, A, B, C, O. So corner points are so O corner point is 0 comma 0. A corner point 0 comma 3 and B corner point is 20 by 19, 45 by 19, and then C corner point is 2 comma 0. Okay, so what question is demanding? We have to find out the maximum value of the Z, right? So now all these corner points, let's substitute in the Z. Totally we got the 4 corner points. So in the Z, if you substitute, what is the given Z here? 5x plus 3y. 5x plus 3y. So first corner point 0 comma 0, 0 comma 3, 20 by 19, 45 by 19. Next one 2 comma 0. 0 comma 0, if you substitute it here, what is the Z value that will get? 0 only. 3 if you substitute, 0 comma 3 if you substitute, 5 times of 0, 0 plus 3 3s are 9. So 9 we will get. Now let's substitute this value. 5 of 20 by 19 plus 3 times of 45 by 19. So what we will get? 5 into 20 times, which is 100. So we will get 100 by 19 plus, and 45 into 3 gives you 135. So 135 by 19. So we are getting 235 by 19. So answer is what? 235 by 19. So what is the approximate value of the 235 by 19? Which is 12.3. 12.36, like that we are getting. Okay, next 2 comma 0, if we substitute it here, what we will get? 5 2s are 10. So 10 plus 0, which is 10. So we are getting 10. So what is the question? We have to find the maximum value of the Z, right? So here, what is the maximum value out of all the four outcomes? 0, 9, 12.36, 10. So which is the biggest value in this? 12.36. So this is the maximum. Okay, so the maximum value of the Z is value of Z is 235 by 19. At what point? What is the corner point? 20 by 19, 45 by 19. Okay, so that's all the solution for this. Thank you for watching and please do subscribe. Thank you.